this screencast, we'll work through quiz 3A, including the details of how to do things in Excel. So our data here is this data set relating growing season temperature, harvest rain, winter rain, and price together for bottles of wine in France over a 26-year period. And the first question we're asked is to find the correlation coefficient between the price of wine and average growing season temperature. So let's remember how to do that in Excel. So we just go into any empty cell in Excel, any empty place, go to Formulas, go to More Functions, go to Statistical, and then we choose down here Correl for correlation coefficient. Where's the data? Well, average growing season temperature right here. We don't include the label at the top. Price of wine right here. Don't include the label. And here's our answer, 0.66 basically. So that's a positive correlation, moderately strong. So here's our 0.66. And this tells us, so the fact that it's positive tells us that the warmer the growing season, the higher the temperature, the more wine will cost. And that it's a moderately strong relationship. So it's no guarantee that a season which is a little warmer, the wine will cost more, but that's the general trend. So that's how we do that one. Then it says, find the equation of the regression line predicting price from AGST. So how do we find the equation for the regression line? Well, we need to make a scatter plot. And remember, when we make a scatter plot, x comes before y. The explanatory variable, the thing we're using to predict, comes before the response variable, the thing we want to predict. So we want to predict the price. So we need to take this AGST and have it right to the left of price. I'll just get rid of this one, it doesn't do anything for us. Okay, so now we've got it in the order we want. We're trying to predict the price, the y, based on the temperature, x. So first we make a scatter plot. So we select it, go to Insert, go to the scatter plot, there it is, and we see how price and temperature are related. Let's just bring it over here. And it does look like a positive relation. It's sloping up roughly. Not very strong, but moderately strong. And then to get the equation for the line, we right-click on one of the data points, add trend line. We tell it to display the equation on the chart. And then we can close this out and drag our equation up. So there's our equation, y equals 0.63x minus 3.42. And that's how we have it here. Predicted price, that's our y in the Excel, equals 0.63 growing season temperature minus 3.42. Or if you want to use y's and x's, y hat equals 0.63x minus 3.42. The hat reminds us that we're talking about the predicted price, not the actual price. So the predicted price in the real world is 0.63 times average growing season temperature minus 3.42. What does the slope tell you? Well, the slope of a line is the coefficient, the multiplier of the explanatory variable. It's the 0.63 here. So that's the slope. The slope is 0.63. Well, what does the slope tell us? Slope tells us how much the output changes when the input changes by 1. So for every 1 degree increase in growing season temperature, every time x increases by 1, the predicted price of a bottle of wine increases by 0.63 euros. So that's the interpretation. The slope always tells you how much y changes when x changes by 1. And then the tricky one, find the equation of the multiple regression model predicting price based on AGST and harvest rain. So now we want to use two variables to predict the price. So for this one we have to use regression. So we go to Data, Data Analysis, and we choose regression. Okay, where's the y range? So first it's saying, where's the thing you're trying to predict? That's here, and we'll include the label, so price. How about the x range? Well, that's these two together. So come over here, choose these two together, and don't forget the labels. And output looks like this. Now, this is a lot of stuff here. It can be tricky to read. Notice, by the way, that the multiple R is 0.84, so that's quite an improvement. But what we need to create our mathematical model is just this piece, these three lines. So we have two kinds of x's, AGST and harvest rain, and they each come with their own slope, 0.60 for the AGST, negative 0.00457 for the harvest rain. And just like with the equation for the line, there's an intercept, that's the negative 2.2. So I'll just copy this so you can see how they show up in the formula. Paste it right here. And here we see how we turn this into an equation. The predicted price, the thing we want to predict, is 0.603, if we round to the 3 decimal places, 3 significant digits, times the AGST, that's this, minus 0.00457 times the harvest rain, and then minus 2.2. Well, if you want to use x's and y's, y hat equals 0.603 x sub temp minus 0.00457 x sub rain minus 2.2. If you use variables, you have to identify what your variables stand for. You can't just put in, certainly can't just have x in both these places because they're not both the same x. And then finally, to find the predicted price of a bottle of wine, if AGST were 18 and harvest rain was 50, put in 18 here for AGST and 50 for harvest rain and do the arithmetic. 0.603 times 18 minus 0.00457 times 50 minus 2.2, and you'll get about 8.43 euros. So please ask me if you have questions about this, but I want you to be able to do these things. They can be kind of confusing the first time you see them, but they're not that hard.